Hello, Matthews Gatos here. Welcome to part 2 of 3.2, the word problems. Before I get into word problems, I just want to review with you what we did in 3.2, part 1. So in this question here, I have something in vertex form, and I want to write it in standard form and then determine the values of A, B, and C that go along with that. So let's do that by writing out my quadratic first. So x minus 1 squared, I'm going to write out as x minus 1 times x minus 1 plus 3. Now I'll distribute the negative 2 inside the brackets, only to my first set of brackets. And then I'll apply the distributive property again. So negative 2x times x is negative 2x squared, negative 2x times negative 1, 2 times x, 2 times negative 1, and then add on the 3. So grouping my like terms, I'll have negative 2x squared. 2x and 2x is 4x. Negative 2 and 3 is positive 1. So that means the value of A is negative 2, the value of B is 4, and the value of C is 1. So a good way to check to see if I'm doing this right, or perhaps maybe a question only asked you for certain values, I have a couple tips here from going from vertex form to standard form. My first tip is that the A value in vertex form is the same as the A value in standard form. So right away, without doing the question, I know that A should be negative 2. My second tip for you comes with the C value. So the C value in this question is really, in standard form, the y-intercept. So all I have to do is find the y-intercept of this, and then I can get the value of C, which I think is a little bit faster than applying all those distributive properties. So maybe if I just asked you for A or C, you could use these tips to help you out. In this question here, we have this function here, y equals a half x squared minus 4x minus 2, and I want to know which of the following statements is false. So first statement, the domain is x such that x is an element to the reals. That is true for all parabolas. Second one, the range is the set of all y such that y is greater than or equal to negative 2. Well, to look at the range, I have to look at my graph. So looking at my graph, I see that it has a minimum, and you can see that that minimum value is negative 10. So the domain should actually be y greater than negative 10, not negative 2. So this one is false. I would choose that as an option, but let's just check the other ones to make sure. If I jump down to D, there is a minimum point at 4 and negative 10. That's my vertex. So I see that that is true. So let's just check our last one. The point negative 2 and 8 lies on the graph. So for this one, what I did is I used my trace. So trace negative 2, and I do get 8. So I know this is true. And in fact, B is the answer. So we're going to be doing word problems. So what I want to do is just take you through a general word problem so we can talk about the different parts of the graph. So, and I'm going to use the example all the way through about a rocket being launched. So I don't have a specific equation. I'm just going to talk about the parts as it relates to this question. So the first important point on a quadratic is the vertex. And the vertex has coordinates P, Q. So P is the value of the variable when the higher low point is reached. Q is actually the high or the low point that it reaches. So if I talk about a rocket being launched, the vertex would show the maximum height of Q and how long it takes to reach that maximum height, which would be at P. Questions can ask you for the y-intercept. So that's when x is 0, what is the value of y? Well, in that case, it would be the initial value, like the starting value. In the example of a rocket being launched, the y-intercept would be the height that the rocket was launched from. So when time was 0, how high above the ground was the rocket? Questions can also ask you for the x-intercept, and that's the value of the independent variable when it crosses the x-axis. So an example of that with the rocket being launched, well, first of all, you can see that the negative x-intercept does not make sense because you can't have negative time. However, the positive x-intercept would be the time it takes for the rocket to reach the ground when it lands. Another thing that the questions can ask you for is the domain and the range. So domain and range is not domain and range of a parabola. It is within the context of the question. So what value is the independent and dependent variable? So for example, if we look at this path of a rocket, time can't be negative. So my domain would be, my smallest value of x would be 0, up to when it landed, which would be my positive x-intercept. So in between 0 and when it landed, this would be my domain. Now, my range is for y, and my range is the height. Now, height also can't be negative. So my height would be from a height of 0 to my maximum height. So this would be my range from 0 to my maximum height. So for every question, it's going to be a little bit different. We have to look at the context of the question. So I want to take you through this example here, and I'm going to ask you a bunch of questions. I would never ask you this many questions on a test or a quiz, but it gives you an idea of all the possible types of questions that you could be answered or asked. So in this question here, we have a diver that somersaults from a 2-meter springboard. Her height, h meters above the water at t seconds, is modeled by this question. So what I always like to do is my h of t, which is my y value, is height. I just want to know what my variables are. My t value, which is my x, is time. So you know when I'm asked for a certain parameter, you know what you're really being asked for. This is the window setting that I used, and I'm going to have graphs to show you all the way through. So first question I'm asking you for is, what is the diver's maximum height? Well, as soon as I hear that word maximum height, that means I am looking at my vertex. Now, what is my maximum height is the y-coordinate, or q, of the vertex, which is this one right here. So I can see, answering this question here, that my maximum height with units, 3.7 meters. Now, let's look at the next part, which is saying, when does it occur? So I just want to get a different color here. So when does it occur? Not what it is, but when does it occur? That is in your vertex, that is your x-coordinate or your p-value. So this is the when. So this is when it happens, whereas the y-coordinate is what it is. So when does she reach her maximum height? Well, she reaches her maximum height at 0.6 seconds. Because it's a word problem, don't forget your units. What is the y-intercept and what does it represent? So y-intercept is the value when x is 0. So when x is 0, I'm going to use a trace. So I use my trace function. So I do trace of 0 equals to 2. Now I could also see in the equation that it's just the constant, the lonely number. So the y-intercept of 2 is the initial height. So she's starting 2 meters above the water. Next question. At what time does she hit the water? So when she hits the water, she has a height of 0. To have a height of 0, that's a y value of 0, I am asking you to find the x-intercept. And only the positive x-intercept, because here time can't be negative. That makes no sense. So I find the x-intercept, and that is 1.5. So she hits the water at 1.5 seconds. So again, as we're going through these questions, I want you to see what the question is asking and what important point that is tied to. Next one, what is the height of the diver 0.3 seconds after leaving the board? So 0.3 seconds, that's why I wrote out what my parameters were, my values of my variable. That's a time value or an x value. So it's saying x is 0.3, what is y? So I'm going to use trace, because trace is give the calculator the x, it will give you the value of y. So I do that on my calculator, trace 0.3, enter, and I can see that the height, rounded, 3.3 meters. Next one, when does she first reach a height of 3 meters? So 3 meters is a y value. So this is an example of y given, x needed. Well, when we have y values, those go into y equals. That's the only place they can go into. So y values go into y2, and then you find the x-coordinate of the point of intersection. So in y2, I'm going to put 3, which you see I do here, and I want to know the first time. That's what it said, the first time. The first time she reaches that height of 3 meters, that's the x value, is 0.2 seconds. Now, what if I didn't ask the first time? I just said, when does she reach a height of 3 meters? Well, in that case, I would want both points of intersection. I would want both of these values. But since I was only asking for the first time, I only wanted the first value. And then the last one, what is the domain and the range? So my tip for you with the domain, time can't be negative. So domain is from time equal to 0 to the time she hits the water, which was that x-intercept, which we already calculated. So my domain is going to go from 0 to 1.5. So the set of all x such that x is greater than 0 but less than 1.5, but still an element of the reals. Now for my range, range has to do with my y values, and those are height. Well, height can't be negative. So range is from a height of 0 to the maximum height. So I can look at that there and see that the maximum height up here is 3.7. So range is the set of all y such that y is in between. Oh, and there's a little typo there. Let's change that to a y. That y has to be greater than 0 but less than or equal to 3.7, still an element of the reals. Okay, so again, this is, I would never ask you this many questions, but you can see as you're going through this, what points am I asking you for? Am I asking you to find an x value given a y? Am I asking you to find a y value given an x? Am I asking you for the x-intercept, the y-intercept, or the vertex? So let's try another question here. We have a farmer that wants to enclose a rectangular field with 600 meters of fencing. I want to know the maximum area that can be enclosed. Okay, so we have two things going on here. We have area and we have perimeter. So my tip is we want one equation with only two variables, because right now I have area, length, and width. That's 3 variables. That's too many. So let's go to the perimeter. I was given that the perimeter is 600. So 600 is 2 lengths plus 2 w's. Now I notice that everything there is divisible by 2, so I'm just going to divide everything by 2. To be fair, it's an equation, it's balanced now. So 300 equals length plus w. So I'm going to isolate one of my variables, doesn't matter which one. So in this case I chose length. So length is 300 minus w. So I'm going to replace that with the length right here. So instead of having area equals length times width, I'm going to have area equals length times width. Okay, so now I have an equation with only 2 variables, area and w. My second tip to find the maximum area, we need to find the vertex. So anytime you hear that word maximum or minimum, you are being asked to find the vertex. So let's look at how we find our vertex. So very first thing that we're going to do is put our equation into y1 and find our vertex. So let's go ahead and do that together. So go into y equals, and we're going to put 300 minus x, and then multiply that by our x value. Okay, so because it's a word problem, zoom 6, my standard window setting, probably not going to do it. So what I recommend doing is just do zoom 0 first. So zoom 0, if we go to the bottom here, zoom 0 is zoom fit. The calculator does a window it thinks fits. It's just a starting point though. So if we do zoom 0, okay, it thinks that that's a good window setting. The very first thing I do is go into my window and I make x and y 0 for my minimum. I always make those 0 because I can't have negative values. So in this case, I can't have a negative length or width. I can't have a negative area. And when I look at my graph, I see that is not helping me. I need to find a vertex. So I can imagine this is part of my parabola, and it's going to come up and then it's going to curve around. So what I need to do at this point here is I want to make my X and my Y values bigger. So let's just go back here. So window setting, I just did zoom 0, okay? And I went into my window and I set it equal to 0. The minimum of X and the minimum of Y. The reason is the graph for word problems will only be in quadrant 1 for word problems because X and Y both have to be positive. Okay, so you can see when we did zoom 0, we did this graph, and this does not help us at all. So I need to see more values. So if I want to see more X values along here, then what I need to do is I need to make my X values bigger. So over here, I'm going to make my X values bigger, and I also need to make my Y values bigger as well. So to see more of the graph over here, make X max bigger. To see more of the graph up here, make your Y max bigger. And you can do this a couple of times until you kind of get it right. So you can see what I adjusted my windows to here. And this is probably after fiddling with them a couple of times because I want to see the majority of the graph, so nicely and spaced out. So as you adjust your windows, if you still need to see more over, make the X bigger, make the Y bigger, and just keep going until you get a nice shaped graph. So now that we've got that nice shaped graph, we just have to go ahead and find the vertex. So to find the vertex, we're just going to go to the left of the vertex, to the right of the vertex, press enter, and find that maximum value. So let's go ahead and let me just show you that. So we'll make our windows bigger. We'll go, I think it was up 300. And then we'll go up to here. I can't remember what it was. Let's try 30,000. And we'll go up by, say, 1,000. Let's see if that's good. There we go. Okay, so to find my vertex, I go second trace. So remember, it's either trace or second trace. And I go in and find maximum, which is option 4. So I just go just to the right side of it, press enter. And then just around to the left side, press enter. Enter one more time. And there I get my maximum value, my vertex. So all that's left is we just have to interpret that maximum now. Okay, so my tip for you when it comes to the vertex is that the x coordinate P is when it is, and the y coordinate Q is what it is. So if you look at your vertex, we have a vertex at 150 and 22,500. So what it is the maximum area. So the maximum area, 22,500 meters squared. I believe my units were meters squared, were they not? Let's just check. Yes, it was meters. Okay. What dimensions will give it? Well, this is when it happens. Now, when we did our formula, we isolated, to go back over here, just to refresh your memory, we isolated and just had W's. So the when it is when I have a width. So this is the width, and this is the maximum area. So I know that the width is 150 meters. So to figure out the length, let's use what we isolated for, which was 300 minus the width. So the length is 300 minus 150, meaning that the length is also 150 meters. So the dimensions are 150 meters by 150 meters to give it that maximum area. So remember, with the vertex, the y-coordinate is what it is. What is the max? What is the min? The x-coordinate is when does it happen? Okay, let's talk about domain and range, last part of the question. So I have all my points labeled here. I'm going to put my vertex in the middle, which was again 150 and 22,500. Okay, so that's really all I need to know for domain and range. So domain is along the x-axis, what's happening with the values. So the domain is along here. It goes from 0 up to 300. So it's in between 0 and 300, but still any other real number. Let's look at the range. The range is the height, so I can have a height of 0 up to the maximum, which is a height of 22,500. So it's going to be between 0 and 22,500, where still y is an element of the reals. Okay, so a little joke for you here, how I see math problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Answer, purple, because aliens don't wear hats. This joke came from my daughter. She thought it was really cute. And I said, Amber, that doesn't make any sense. And she's like, neither do math word problems. So hopefully you understand math word problems from my lesson and can go on and do my questions, numbers 4 to 6. Detailed solutions are on D2L. And then you can move on to your textbook questions. So I hope that this video helped, and I look forward to seeing you for the next one.